Okay, so good afternoon. Today's topic is physical properties of carboxylic acids, and then we will continue with acidic strengths of carboxylic acids, right? So physical properties में first we will take into account the smell. Okay, so as per this carboxylic acids, first three for carboxylic acids, first three members, what are their name? Can you tell? First three members, that is formic acid or acetic acid and propionic acid are liquids with pungent with pungent smell. Okay, spelling is right, with pungent smell. Am I audible to you? Hello. Am I audible? Yes. And next, from C4 to C10, C4 to C10 are oily liquids with unpleasant smell, like butanoic acid, or is also called butyric acid, has a rancid butter type smell. Okay, and next 10 onwards, okay, next higher members, they are waxy solids with no characteristic smell, okay. And what about aromatic carboxylic acids? Yes, कौन कौन प्रेजेंट है? No, tell me why they are pungent smell and then with some unpleasant smell, and at the end they are waxy solid with no characteristic smell. It is because of low volatility, because if they are not volatile, then we cannot see the smell. Okay, same is the case with aromatic carboxylic acids. In aromatic carboxylic acids are crystalline solids. See the difference, they are crystalline solids. Okay, with no characteristic smell, right? So this is about their physical state and smell. So you know that physical state, they are liquids, then slightly oily liquids, and at the end they are waxy solids. Aromatic are crystalline solids because their molecular mass increases, number of electrons increases, size increases, so van der Waals attraction increases. And why they start from liquids? Because there is hydrogen bonding between they always form dimer. Okay, right, this problem has been solved. the voice clarity, right? So this is the first part. Now come to their solubility in water. So next page. Okay, so second is solubility. So in solubility, you know, what about their solubility in water? Are they soluble in water or not? Yes, tell me. They are carboxylic acids are water soluble or water insoluble? Yes. Are they water soluble or insoluble? Oh, Ashish, carboxylic acids are soluble in water, at least lower carboxylic acids, because you know carboxylic acid, they can form hydrogen bond with water. They can form hydrogen bond with water. Means lower members are soluble in water, but higher members solubility decreases. Solubility decreases as number of carbon atoms increases. Why is it so? Because when number of carbon atoms increases, new hydrocarbon part increases, so hydrogen bonding becomes less efficient, right? Because of increase in the hydrocarbon part, means hydrophobic part, so solubility decreases because effect of hydrophobic part. If effect of hydrophobic part increases, then solubility decreases. If effect of hydrophilic part, that is hydrophobic part is alkyl group and hydrophilic part is COH. So as R increases, effect of COH decreases, so solubility decreases. This part increase the solubility and hydrophobic part decrease the solubility. Okay, so this is about solubility. Now next is boiling point. First thing, if we compare carboxylic acids with alcohols, you know, alcohols have higher boiling point than aldehyde and ketones. Aldehyde ketones have higher boiling point than ethers or hydrocarbons because alcohols involve hydrogen bonding. So carboxylic acids, they also involve hydrogen bonding. But which one has higher boiling point? Tell me. Order is carboxylic acid has higher boiling point than alcohols, which in turn higher boiling point than carbonyl compounds, higher than ethers or hydrocarbons. Of comparable molecular masses, right? Why carboxylic acid has higher boiling point than alcohols? See, in alcohol, hydrogen bonding there is a simple hydrogen bonding. Okay, but in carboxylic acids, there is hydrogen bonding in such a way that they form dimer even in vapor phase. That means they are always existing as dimer. As they exist as a dimer, so their molecular mass is always double as that of its single molecule. Okay, like ethanoic acid. So in ethanoic acid, what is its molecular mass? Its molecular mass comes out to be 24 plus 32 plus 4, 60. But as per freezing point depression, its colligative property, its molecular mass comes out to be 120. So what it indicates? That it always exists as a dimer. Okay, and that's why their boiling point is always higher than that of alcohols of corresponding molecular masses. And as the number of carbon atoms increases, obviously boiling point goes on increasing, right? If we have acetic acid, propanoic acid, butanoic acid, then butanoic acid has higher boiling point than ethanoic acid. Ethanoic acid has higher boiling point than acetic acid. Done? Okay, now melting points. So keep in mind, melting point has no regular trend. In melting point, there is no regular trend. Why is it so? Because here there is a lattice, and the molecule which are better fit in the crystal lattice has higher melting point. So see, if we have say let it be of 1, 2, 3, 4, 5. So 5 carbon atoms, then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and 7. So tell me, out of these three, which one is more symmetrical? Which one is more symmetrical? Out of 5-membered, 6-membered, and 7-membered carboxylic acids, which one is more symmetrical? And more symmetrical is better fit in the crystal lattice, so has higher melting point. Yes, out of these 5-membered, 6-membered, and 7-membered, which one is more symmetrical? Respond fast. Which one is more symmetrical? Jaldi, jaldi. Which one is more symmetrical? बेटा जल्दी बोलो. See, in this case, CH3 and COH both are on the same side. Here, CH3 and COH are on the opposite side, same side. That means even numbered carboxylic acid is more symmetrical so its melting point is higher than that of its lower, immediate lower and immediate higher members. Okay, for example, here 6-membered has higher boiling point than 5-membered as well as 7-membered. Otherwise, there is an increase in melting point, and that is called alternation effect. This is called alternation effect. Okay. So this is about boiling point, melting point, smell, and solubility. Okay. Next, chemical properties. Okay, wait. Shh. Shh. कौन कौन है, मुझे तो समझ नहीं आ रहा कि आप हो भी अभी के नहीं। एक तो आशीष होगा, बाकी क्या अटेंडेंस लगा के चले गए? साध, वरुण, आशीष, चरित्र, कौन कौन है? कौन कौन प्रेजेंट है? बोलो। ओके, थैंक यू। So chemical properties में first tell me out of carbonyl carbon and carboxyl carbon, which one is more electrophilic? Out of carboxyl carbon and carbonyl carbon, which one is more electrophilic? We have discussed it earlier. So in this case, you know, because of resonance, carboxyl carbon has less positive charge than carbonyl carbon. So carboxyl carbon has less positive charge than that of carbonyl carbon, right? So carboxyl carbon is less electrophilic. Carboxyl carbon is less electrophilic, right? Second thing, acidic character of carboxylic acids or reactions involving OH bond cleavage. So in these reactions, see, we have RCOH, and second thing, keep in mind that I have talked about that dimer formation that takes place in aprotic solvents only. Otherwise, if it is protic solvent, then you know ionization takes place. Dimer is formed in aprotic, means which cannot give protons, right? Aprotic solvents only. So RCOH like in benzene, but if COH means carboxylic acid is in water, then ionization takes place. We get carboxylate ion along with hydronium ion. So dissociation constant of carboxylic acid, it is denoted by Ka and is equal to RCO negative H3O plus divided by RCOH. Water is concentration is constant, so this is dissociation constant of acid, right? And second is pKa, that is equal to minus log of Ka. So higher Ka or lower pKa, because if Ka is higher, pKa is minus log of Ka, so lower pKa, the stronger is the acid. Higher Ka or lower pK, then stronger is the acid. Okay, Harshil. कृष्ण कुमार, क्या समझ में नहीं आ रहा है बेटा, बोलो. And you know, because Ka is directly proportional to concentration of carboxylate ion or concentration of hydronium ion. So more is the ionization of the acid, more is the Ka value, so stronger is the acid, because it gives more H plus ions, then it is a stronger acid. Yes बेटा, क्या समझ में नहीं आ रहा है? Now that means acidic strength of carboxylic acid is proportional to stability of carboxylate ion. See, this is the carboxylate ion and this is the group attached. This group may be electron releasing or withdrawing, right? First of all, carboxylic acid is an acid because carboxylate ion involves delocalization of negative charge. In carboxylic acid, there is separation of charges. So if question is why carboxylic acid is an acid, then we write that carboxylic acid is less resonance stabilized than that of carboxylic acid is less resonance stabilized than that of carboxylate ion, because carboxylic acid involves charge separation. Carboxylic acid involves charge separation and carboxylate ion involves delocalization of negative charge. That's why carboxylic acid is carboxylic acid behaves as an acid, right? Okay, good afternoon, Swati. Got it? So why carboxylic acid is an acid? Because carboxylate ion is more resonance stabilized than carboxylic acid. Why carboxylate ion is more resonance stabilized? Because carboxylate ion involves delocalization of negative charge, but carboxylic acid involves charge separation. Okay, so carboxylic acid behaves as an acid. That means any group which decrease the negative charge or stabilize the carboxylate ion, that increases the acidic strength. So tell me, which groups stabilize which type of groups increase the acidic strength? Tell me. Or sorry, which type of groups decrease the negative charge on carboxylate ion or stabilize the negative charge? I will write, you will say which type of groups: electron withdrawing or electron releasing groups increases the stability of carboxylate ions by decreasing or delocalizing negative charge. Ashish beta, electron withdrawing groups. See, electron withdrawing groups. If there are electron withdrawing groups that decrease the negative charge, because that snatch or electron density that will withdraw the electrons from the carboxylate ion, so decrease the negative charge. And if negative charge is decreased, it becomes stable, because delocalization of negative charge stabilize the carboxylate ion. Okay, so electron withdrawing groups increases the stability of carboxylate ions, okay, by decreasing or delocalizing negative charge. So which in turn increases acidic strength, which in turn increases acidic strength. That means electron withdrawing group increase the acidic strength. And what about electron withdrawing groups? Sorry, electron releasing groups. Electron releasing groups decreases the stability of carboxylate ions by increasing or intensifying the negative charge which in turn decreases the acidic strength. Yes, because say this is RCOH in equilibrium with GCO negative plus H plus, or if you write water as well, so it is H3O plus. See, if it is stable, then equilibrium shifts forward. If it becomes more stable, equilibrium shifts forward. If it becomes less stable, equilibrium shifts backward. So more stable, more acidic. If carboxylate ion is more stable, carboxylic acid is more acidic. If it is less stable, equilibrium shifts backward, so it becomes less acidic. That is the case, right? Now let us try few. Formic acid, acetic acid, propanoic acid. Tell me, what is the order? Which one is more acidic? See, groups are H, CH3, CH3, CH2. Take it as A, B and C. So what is the order of acidic strength? Which one is more acidic and which one is less acidic? Simple, write the order A, B, C. Write the order first. Yes, very good. A, because plus I effect increases. Ethyl is more electron releasing than methyl, which in turn more than hydrogen. Means electron releasing effect increases. So acidic strength decreases. Ashish, you are right. A is more acidic than B. B is more acidic than C. Order is A, B and C. Because as electron releasing effect increases, carboxylate ion formed becomes less stable and so acidic strength decreases. So A is more acidic than B, B is more acidic than C. That means as number of carbon atoms increases, acidic strength decreases. Like we have CH3, CH2, CH CH3 CuH. Second is CH3 CH, CH3 CH2 COH, and third one is CH3 CH2 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 COH. So tell me, what is the order of acidic strength? A is greater than B is greater than C beta. What about this? In last case, A is more acidic than B, B is more acidic than C, because electron leasing effect increases. Now in this case, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 means all have 5 carbons, and except COH there are 4 carbons. So which one is more electron leasing? And again ABC. In this case, what is the order? Say methyl group, it is closest to the COH. Here it is away from COH, furthest from COH. Okay, so keep in mind, as we go in this series, plus I effect decreases, because as distance from COH increases, so plus I effect increases, so it decreases. So that means electron releasing effect decreases. So acidic strength increases. Acidic strength increases. That means order is like this. Very good, Harshil. Swati, great. So in this case, C is more acidic than B, B is more acidic than A. Done? Okay. So tell me, if I have CH3 CH2, or let it be like CH2 Cl COH, Cl CH Cl COH, or Cl 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 COH. So tell me, what is the order? Again, on the same page, so I write it as D, E and F. D, E and F. Yes, D, E and F. Okay, Harshil, A, B, C, good. D, E, F. Is it? See, there are electron withdrawing group. Only one electron withdrawing group. There are 2 electron withdrawing groups, 3 electron withdrawing groups. So as number of electron withdrawing groups increases, as we go along this series, number of Cl atoms increases, so minus I effect increases, minus I effect increases, so acidic strength increases. That means trichloroacetic acid is more acidic than dichloroacetic acid, which in turn more acidic than monochloroacetic acid, right? Now fluorine, chlorine, bromine, iodine. What is the order of acidic strength? Fluoroacetic acid, chloroacetic acid, bromoacetic acid, iodoacetic acid. Fluoro, chloro, bromo and iodo. Or this is a simple application of inductive effect. 1, 2, 3, 4. Ashish. Very good. Because fluorine is more electronegative. Harshil, good. Chlorine is less than fluorine, then bromine, then iodine. Because minus I effect, order of minus I effect is fluorine is then chlorine, then bromine, and then iodine. Swati, very good. Means you have written in increasing order. 4 is less than 3, then 2, then 1. Okay. So fluorine, chloroacetic acid is more acidic than chloro, then bromo, and then iodo. What about this? 2-chloro, 1, 2, 3, 4. Butanoic acid, 3-chlorobutanoic acid, and 4-chlorobutanoic acid. They are chlorobutanoic acid, 2-chloro, 3-chloro, and 4-chlorobutanoic acids. So order is yes, because minus I effect is maximum in first case, less in second case, and least in third case. So order is 2-chlorobutanoic acid is more acidic than 3-chlorobutanoic acid, and then 4-chlorobutanoic acid. That's it. Okay. Now let us. Very good. I think you people know about this. That's great. Now let us talk about benzoic acid and formic acid. Let us compare acidic strength of benzoic acid with formic acid. So tell me, out of benzoic acid and acetic acid, which one is more acidic? Benzoic acid and formic acid. Out of benzoic acid and formic acid, which one is more acidic? Very important question. Great. formic acid is stronger acid than that of benzoic acid. Can you tell me why? Why is it so? Why is it so? Because in this case there is H. If we compare H with phenyl ring, so if we talk about minus I effect, so phenyl ring has higher minus I effect than hydrogen, but at the same time there is plus M effect, resonance, mesomeric effect. So plus M effect of phenyl ring is greater than hydrogen, and this plus M effect is dominating. So that means it behaves as an electron releasing group. This is behaving as electron releasing group, and there is no electron releasing effect, or we can say there is no electron releasing group, and that's why benzoic acid is weaker acid because of its more electron releasing power of phenyl ring, and that's why benzoic acid is weaker acid than that of formic acid. Ranjan ji, you can start anywhere. It takes only 2 months to prepare for NEET exam if you are dedicated to the preparation, towards the preparation. Okay, so better to start now rather than thinking about that. Okay, result is not in your hand, but preparation is in your hand. So if you continue to ask like, may I get such marks, so it depends upon your preparation, okay, your dedication towards study. So start now and now look back. Okay, all the best. Now let's have benzoic acid, paramethyl benzoic acid, para-nitrobenzoic acid. Tell me, what is the order of acidic strength? Benzoic acid, paramethyl benzoic acid, and para-nitrobenzoic acid. What is the order of acidic strength? Or even you can take into account para. Okay, 1, 2, 3. Ashish, wrong. See, methyl group has plus I effect, nitro group has minus I as well as minus R effect. Para-nitrobenzoic acid, see, this is electron withdrawing group. This is electron releasing group. Electron releasing groups decreases the acidic strength. Electron withdrawing groups increases the acidic strength. And what about this? This has minus I and plus R, minus I and plus R or plus M you can say. So it is also electron releasing group. One wrong, Ashish. Tell me, out of these two, they are electron releasing groups. So electron releasing groups are more increase the acidic strength or decrease the acidic strength? Electron releasing groups, we can write here, electron releasing groups increases the acidic strength, okay, and electron withdrawing groups, electron releasing groups decreases the acidic strength, electron withdrawing groups increases the acidic strength. Right, Ashish, decreases. That means second and fourth are weaker acids than first, because in first there is hydrogen only, but third is more acidic than first. Third is more acidic because it is nitro group, withdrawing group, and out of second and fourth, fourth in this case OCH3 has plus R effect, so it is more electron releasing. So that means fourth is weakest, and then second, then first, and third one is maximum acidic strength. Did you get it? Any doubt? Just tell me, fourth, second, first, third. Is it right? Most acidic is third, and least acidic is paramethoxy benzoic acid, because paramethoxy has more electron releasing effect. Okay, so in the next lecture we will talk about ortho effect and its applications. So this is a simple case, or we can go through all the acidic strengths, which are very simple. There is one thing, electron withdrawing group increases the acidic strength, and electron releasing groups decreases the acidic strength. That is the main thing here. Out of benzoic acid and formic acid, formic is the stronger acid, so that I have explained. That's it. So thank you very much. Jai Hind, Jai Bharat. Bye. कोई डाउट है तो प्लीज डू आस्क. कोई डाउट नहीं है? चलो बाय फिर.